Is recording.
Yeah, okay. So second half of the June 2017 Intermediate Maths Paper 1. So we're into the grade pushing into the C and B questions. Kerry's a set of cards. Each of her cards is labelled north, east, south or west. Kerry chooses one card at random from her set of cards. Complete the table below to find the probability of Kerry choosing a card labelled west. So you need to know that probability all adds up to 1. So here I've got 0.4, 0.6, 0.85 already. So to make that up to 1, I've got another 0.15 to make. Kerry chooses one card at random from her set of cards. What is the probability that the card is labelled east or south? Or trigger in maths in probability is add. So east or south increases your chances. So you're going to add them together. So that would be 0.25 plus 0.2, which is 0.45.
So and would be minus.
No, and would be times.
And would be times.
Okay. So Sasha is an identical set of cards. Kerry and Sasha each choose one card at random from their sets of cards. What's the probability they both choose a card labelled north? So that means Sasha chooses north, 0.4, and Kerry chooses north. And in probability, and means times. So you're doing 0.4 times 0.4. 4 fours is 16. Two numbers after the decimal point in the question. So there need to be two numbers after the decimal point in the answer. So 0.16. So when we're into the second half of the paper with probability, anding and oring are likely to be what they're testing you on. Or means add because it increases your chances. Yeah, because you're saying, well, it's this or this. And decreases the chances. So you multiply the probabilities. Marks for that one. So a method mark for adding them up and taking away from 1. I'll put that there. And an answer mark. And then same for this one, a method for adding the correct 2 and an answer mark. And for this one, method for 0.4 times 0.4 and an answer mark. So there's 6 nice marks there, but you have to be tuned in to the anding and oring. Question 11. So this comes up a lot. This came up on last night's paper as well. So as soon as you see this, as soon as you see that you're given a piece of algebra that they want to turn into a graph, it usually links y and x because you've got your x and y coordinates, and it's usually an x squared. And an x squared means you're either going to end up with a nice smooth smiley curve or a nice smooth negative curve, sad curve. But what you shouldn't end up with is something that suddenly does that or does that. If you get something like that, it means you've worked out the points wrong. So when we did this in class, what I suggested you did was plot the points they give you first up, because it helps you estimate what number you should be getting in that box. So x coordinate -1 against 8, x coordinate -1 against 8, 0, 2, 1, -2, 2, -4, 3 I don't yet know, 4, -2, and 5, 2. So looking at those points, I'm expecting a happy smiling face like that. So to get that, I'm looking for this cross here, John, to be kind of there in the -3-ish area, or possibly a bit lower. So then I'm going to work it out. So y, instead of the x, I'm replacing it with a 3. And remember, where I replace the letter, I get brackets. So the x has become a 3. 3 squared is 3 times 3, which is 9. 5 threes are 15. That's negative. That's positive. So that's going to become negative. Signs are different. Plus 2. So 9 add 2 is 11. Take away 15 is going to be negative 4. So negative 4 is there. So that's all right. That will work because it will come down just below it. In class, I then say make sure you're using a pencil in case you mess it up. And then I tell you, when you're drawing the curve, it's supposed to be freehand, and your wrist is a great curve maker. So you put your wrist on the inside of the curve you're going to draw, which is why I've turned the paper upside down. And then using a pencil, not a ruler, you build the curve. Like that. Okay, then they usually make us do something with it. So what's it asking us to do next? Draw the line y equals negative 3 on the graph paper. So y equals negative 3. The most common mistake people make is they think y equals is a vertical line. Y equals goes through the y coordinate minus 3, which is there. So the line y equals minus 3 is a horizontal one. Okay, so we've done that. Then it says, write down the values of x where the line y equals negative 3 cuts that curve. So all we need to do is to look, it cuts it there. So you want to read off that value, which is 1.4. And this value, which is about 3.6. And you want to do that as accurately as you can, but there will be, because you've drawn a freehand curve, there will be a margin of error that they will allow. And I'll tell you what that is in a minute. So, marks for that. Question 11. 1 mark for the negative 4. 1 mark for that. For this, there's a P mark for plotting the points, and a C mark for the nice smooth curve. And then 1 mark for drawing the line y equals minus 3, and 1 mark for the two values. The ones printed on the mark scheme are the same as I got, 1.4 and 3.6. And you see there, allow plus or minus 1 small square. So if you were 1 square out either side, they give you the marks. Question 12. Express 700 as a product of its prime factors in index form. So this is a trigger of something you're looking to do. It's when you break this down with a tree where you're repeatedly dividing by prime numbers. So we start with 700. It's even, so first prime number to divide in is 2. 2 goes into 700 350 times. That's not prime, but it's still even, so I can divide by 2. That is 175. So I can't divide by 2 anymore. But it ends in a 5, so I know I can divide by 5. I don't know how many times, so because it's a non-calculator paper, I've got to go and do that division. 5 goes into 17 3 times remainder 2, and into 25 5. So 5 goes into that 35 times. That's not prime, because 5 goes into it 7 times, but that is prime. So when all my branches are prime numbers, I've finished. So 700 is 2 times 2 times 5 times 5 times 7. But the question wants that in index form. 2 is multiplied by itself twice, so that's 2 squared times 5 squared times 7 to the power of 1. Okay, if you'd have just written that as 7, it's fine. Okay? But if a supplementary question there could be asking, is that, do we know if 700 is a square number or not? Okay? And because that is an odd power, it's not. Square numbers, all the powers would be even. They don't have to be the same. So if that was a 4, it would be a square number. Because I've written the 1 there, I can see that it's odd. So that's why it's worth putting in. The number that is equal to 2 to the power of 25. Explain how this tells you that that number is not a square number. Goes back to what I was saying. The power is odd, so it's not. So all you need to say is because the power is an odd number. So for that we've got the method mark of repeatedly dividing, an answer mark for writing it like 2 times 2 times 5 times 5 times 7, and then 1 for writing it correctly in index form, and the explanation there that the power is odd. Okay, so then we start hitting now the topics that we haven't covered in class. Okay, this is topic number 1. Which one of the following equations could represent the line shown in the graph above? So, an equation of a line is generally written in these standard sections. You've got that which is your y coordinate, that which is your x coordinate. This value tells you how steep the curve is, okay, the gradient. And this value tells you where it crosses the y-axis. Okay? As far as the gradient is concerned, if it's travelling uphill, it's a positive gradient. If it's travelling downhill, it's a negative gradient. So I'm looking at that line, and I know I'm looking for a negative gradient. Okay? So it could be that one. It could be that one. It's definitely not that. It's definitely not that. Could be that one, because those three have got negative gradients. Now, I can see that this is crossing the y-axis at a positive value. Yeah, there's no numbers on it, but I know that's going to be plus something. Which means it can't be that one, because that's got a negative value. Could be that one, and it can't be that one, because that one hasn't got, that's plus 0. So the only one of those that it can possibly be is that one. Okay? Because it's got a negative gradient, it's going downhill, but it's got a crossing the axis, the y-axis, at a positive place. Part B. Which one of the following points lies on the line 2y equals 3x plus 4? So when you're given coordinates in a bracket, the first value is the x value, and the second value is the y value. Okay? So in this equation, 2y, if I highlight that so we can see it easier, all I'm going to do is take my coordinates that I'm given, so 2y, well y is negative 5, so 2 negative 5 equals 3x plus 4. Okay, and let's see if that balances. So 2 times negative 5 is minus 10. That equals 6 plus 4 is 10. It doesn't balance. So that's not on the line. So then I try 5, 2. So 5, 2, the y coordinate is 2, equals 3 times the x coordinate, which is 5, plus 4. So that's 4 equals 15 plus 4 is 19. They don't match.
Wait, so it's always x on the left?
Yeah, in a coordinate, x is always the first digit, y is always the second.
Okay.
So where have I got to? This one, minus 2, 5. So 2, the y coordinate is 5, equals 3, the x coordinate is negative 2, plus 4. 2 times 5 is 10, equals minus 6 plus 4. So 10 is equal to minus 2. No, it's not. So it's not that one. So then I come to 2, 5. So 2, 5, 2 bracket 5, equals 3, x is 2, plus 4. 2, 5 is 10, 3 2s is 6, add 4, 10 is 10, so that matches, so it's that one. Okay, so all you're doing is plugging the x and values in to see which pair actually make that balance. And then part C, what is the gradient of the line shown in the graph above? It's uphill, so it's definitely not that one, or that one, or that one. So I've got it down to 3 over 2 or 2 over 3. Okay?
Would it be 2 over 3?
It is 2 over 3. Yeah.
Maybe because it's positive, so where the line crosses in the right is 2, that turns into a positive.
So that's 2, yeah?
Yeah, so would that turn into a positive?
Yeah, because you're talking about the change. All right? If we did that in year 10 or wherever, if we did a lesson on that, the way you find the gradient is it's the change in the y value over the change in the x value. Okay?
So
If we go into A level, we call it difference in y over difference in x. So the change in the y value is 2
so you subtract 0
over,
to 2,
yeah.
and then subtract, okay.
All right?
I get it.
So it's uphill, so it's positive. Change in y over change in x. So there's quite a lot of maths behind those 3 marks. Okay? Question 14. A whole number is written on a card. You're given 3 clues to help you work out the number on the card. Double the number is between 8 and 18 inclusive. So inclusive means it could be 8, it could be 18. So let's write them down. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Those are double the number. So the number is either 4, it can't be 4.5
It has to be a whole number.
because it's a whole number. So it could be 5, it could be 6, it could be 7, it could be 8, or it could be 9. Okay? So that's clue 1. It's one of these. The number is a prime number. So if it's prime, I can knock out all the evens, and I can knock out 9 because 3 goes into 3. So my answer is either 5 or 7. It's not a factor of 100. 5 is a factor of 100 because it goes in exactly. So it must be 7. So with that one, yes, with 3 marks for getting 7. It's 2 marks if you got 5 as your answer, because you just made the mistake at the last but one stage. It's 1 mark if you got 4, 6, 8 or 9, because you've done the halving. So there's quite a different ways you can pick up marks there. Right, we haven't done this. Okay, this is called dimensions or dimensional analysis. Okay, on my website, if it's not in the intermediate page, it's in the higher tier page. There's lots of these. Okay, if this floats your boat, you can learn it quite quickly. It's all to do with units of length being to the power of 1, so it's just centimeters. Units of area to the power of 2, centimeters squared. Units of volume to the power of 3, centimeters cubed. Yeah? So a volume would be something that ends up with just cubes. An area would be something that ends with just squares, and a length would just be length. Okay? So the rules with this are you replace all the letters with just an L. Okay? So replace letters with L. Delete any constants. So like pi is a constant. It doesn't change the units. So we remove any constants. Okay? That 3 there isn't a constant. It's a power. It's telling you to do something. It's telling you to multiply that by itself 3 times. That there is a constant. Yeah. Okay? Because it's just a number. So
is the radius, the r would be a constant?
Right, so it says in here, each measurement of length is represented by a letter. Okay, so with this one, I can replace that. I can get rid of that constant there. Gone. Okay, so I've got L cubed. Take away L squared L. Okay, so L, the D becomes an L, the 3.14 goes away, the R becomes an L, and the H becomes an L, because they're all representing lengths. Okay? So length squared times length gives me length cube. Yeah? Because I'm... Yeah, so I got L cubed take away L cubed. Now, because that's just representing a length, we're not doing algebra here, so L cubed take away L cubed doesn't equal 0. That's saying length cubed is a volume. Units cubed is volume. So I've got a volume, and I'm taking a volume away from it, which will give me another volume.
Okay.
So that's a volume. Okay? So for the second one, I've got L squared plus LL. So that's L squared plus L squared will be an area, because I've got 2 areas. I can add 2 areas together, so that's area. With this one, I've got length plus length plus length, which will give me, no, I'm not multiplying them, I'm adding them.
So it's 3
Yeah, so it's giving me another length, isn't it? It's just giving me a longer length. So that formula will give me a length. This one, I can get rid of the 2 because it's a constant. I can get rid of the pi because it's a constant, and I can get rid of the pi. So here I've got length in the first one, take away length squared in the second one. Length take away area you can't do.
So that would just be L1.
So that's where it says none. Okay, it's not a formula that will work. You can multiply a length by an area, but you can't add a length by an area. They're two different things.
So if it, for example, that L is a cube and L...
It would still be none.
It would be none.
Yeah.
Oh, okay.
Yeah, so if it was L cubed take away L squared, you can't do it. Next one. So I've got length plus length bracket length. Okay? Length plus length gives me another length, just longer one. So that's the same as length times length.
Would be, so squared, so it would be area.
Good, yeah. So that's length squared, so that one's an area. And then the final one, I got length cubed plus length, length, length.
So that would be a volume.
That would be a volume, because L is L cubed. So that one is volume. Right, you got your head around that really quickly, so it's worth you having a go at some of those.
Nice.
All right?
Yeah.
Doesn't come up every year.
Hopefully it comes up this week.
It may well come up next week. So that's good. Well done, John.
Nice.
16.
I can't do this.
Right, now this one is easier than that one. So this one we did in class because it was worth doing.
It's like everything we did in class I don't get. The ones that we didn't
Yeah.
do in class I get.
So a group of 20 people visited Anglesey for a weekend break. 10 of the group visited Beaumaris Castle. So the whole castle circle has to have 10 people in it. Don't put 10 in. 13 of the group visited the lighthouse. So that whole circle has to add up to 13. But we got this middle bit, yeah? 4 of the group didn't visit either of these places. So the 4 doesn't go in the middle, because the 4, that's saying they visited both. This is saying 4 didn't go to either of those.
So it would be outside the box.
So it's inside the box but outside the circle.
Oh yeah.
So because I know that 4 didn't go anywhere,
Do you subtract 4 to 13 and
wait a minute now. How many people are in the whole trip?
10? Oh, 20.
20. If 4 of them didn't go anywhere, how many of them have got to be inside those circles?
Has to add up to 60.
16.
Mm-hmm.
Yeah? But those 10 and those 13 come to 23.
Some of them went to both.
So one of them went to both. Some of them went to both, yeah?
Mm-hmm.
10, so 23 visited a combination, but 16 isn't represented yet. So the ones that did both will be 7. Okay, do you want me to explain that again?
Right, yeah.
So I know that there's 20 people got to be in the whole diagram. And I know 4 of them are out there, which means there are 16 of them inside those circles. But I also know that there are 23 inside those circles as well. So there has to be an overlap. And the overlap is going to be the gap between 23 and 16. So if 7 did both, and 10 visited the castle,
So there'd be 3.
so there'd be 3 there,
And then 13 would be 6.
and there'd be 6 there. So when I add those together now I get 16, and 16 and 4 is 20.
I get it. Oh, okay.
Okay?
So you have to work out
So you have to work out the overlap first.
all that first. Okay.
And that's, yeah, and that's the tricky bit. Okay? Sometimes they'll give you the overlap and then it's a much easier question.
Hopefully.
Okay? If it was on if it's in the first half of the paper, which could be because Venn diagrams is foundation and intermediate and higher, they'd give you the middle. Okay? But if they want to make it harder, you've got to find the middle. One person is chosen at random from the group. What is the probability that this person visited only one of the 2 places? Right, what's it going to be out of, first of all?
Be out of 20.
Out of 20. So only one. So if they visited only one, they're either only going to the castle, or they're only going to the lighthouse.
So would you add up 3 and
6 to make 9.
Okay.
So 3 marks for the Venn diagram, and then 1 mark for the top and 1 mark for out of 20. Okay, something else we haven't done? Simultaneous equations. All the equations we've solved up until now have had one unknown letter, usually x.
Yes.
These ones have got 2. Okay? And what we have to do in algebra is we can only deal with one at a time. So if I just write these to create a bit more space. So the first thing we do is get rid of one of the letters.
How do we do that?
We can only do that if they're the same. So to make them the same, and there's lots of different ways of doing this, but if you want to pick it up quickly, you just focus on the x's. Okay? So to make the x's the same, and to be organized, we number our equations. Okay, so equation number 1 is the first one, equation number 2 is the second. I'm going to take equation 1 and multiply it by whatever the number is in front of the x.
So you're saying 3 times
2.
2. Okay.
And I multiply the whole equation by 2. So I'm going to do 3x times 2 is 6x, 4y times 2 is 8y, and 2 times 7 is 14. Okay, and I'm going to call that number 3.
So that would be what? Alright.
Okay, now I'm going to take the second equation, because what I'm trying to do is make the x's the same, and I'm going to take equation 2 and multiply it by the number that's in front there. Multiply the whole equation by that, I get 6x minus 9y equals 48. Okay?
So that would be 4. Okay.
Now I've got this situation where the x terms are the same. So now I'm going to do subtracting. So I do multiplying first of all to make the x's the same, and now I'm going to take one away from the other. And because that 48 is bigger than that, I'm going to take 3 away from 4. Okay, so I'm going to do equation 4 take away equation 3. Okay, so I'm going to do 6x take away 6x, gone.
So there's no going to be no x.
No x, gone.
No x.
Okay, which is the whole point. So you don't need to write no x, we just leave it as that. We come to here. Here, I've got negative 9 take away 8.
So minus 1y.
No.
Minus 17.
Negative 9 take away 8. So it's going down another 8.
Okay.
And then I've got 48 take away 14, which is 34. To get 1y, I have to divide by minus 17. So I've got to divide the other side by minus 17 as well. So I end up with y is being minus 2.
So that would be 4 marks.
No, because now I've got to work out what x is.
Oh.
Okay, I found out one of the variables, I need to find the other. So now I can choose any one of these equations and replace the y with negative 2. So if I put it in 1, so if I say substitute in 1, I get 3x plus 4, and then instead of y, I got negative 2 equals 7.
Okay.
3x, 4 2s are 8, signs are different. Then I've got to add 8 to both sides.
That's not how I do
So 3x equals 15. So x is 15 over 3, which is 5. So you've got two answers. Y is -2,
So x will be 5.
and x will be 5.
So if for example you didn't choose the top one, if you chose the bottom one, it would still give you 5.
It would still give you the same thing.
Oh,
Yeah?
okay.
The method is that every time. Okay? So given 2, you want to make the x's the same, okay, by multiplying. Then you subtract to eliminate the x's and solve that equation to find y, and then put that back in. Now in the paper that we did last night, it was more horrible than that, because we had to form the equations to start with. It was in a context. That's an easier one than last night, because here's the equations, solve them. Okay? But the method, if you look back at the video from last night, the method is always the same. Make the x's the same, subtract. Be careful when you're subtracting, because sometimes you get minuses and so on. Work out y, substitute in to get that.
Nice.
Marks for that. A method to get down to eliminating, so losing the x. An answer mark for the first variable, the method of substituting in, and an answer for the second mark. Okay, so that's, we're pushing b's now into a's. Okay.
So is there a possibility of me getting an A in this?
No, it's 0.
Damn.
You can't get an A. Okay, so question 18, two questions left, I think, yes. Question 18 again is something I haven't done in class. Standard form, you know, we could take a week on standard form, but we just didn't do. But if I... No, it's not.
It's not.
If I show you the easiest way of doing this, okay? Think back to junior school and hundreds, tens, sorry, what am I doing? Units, tens, hundreds, thousands, and so on.
Yeah.
Okay? And it gets bigger and bigger and bigger. And this way it gets smaller and smaller and smaller from that decimal point. Now, I know that 100 is 10 squared.
100 to 10.
Yeah? So the 100 column has got 10 squared in. The thousands has got 10 cubed in. Yeah? 10 would be 10 to the power of 1, and the unit is 10 to the power of 0. As the numbers get bigger, then the powers increase by 1. As the numbers get smaller, so this side, you'd have 10 to the minus 1, 10 to the minus 2, and so on. Okay? So, when you see a question like this, think, right, if you've got enough room, or go to the back. Decimal point. Then I've got the units. Then I got the tens, 10 squared, 10 cubed. I need to go up as far as 10 to the power of 5 for this number. 10 to the 4, 10 to the 5, 10 to the 6, and so on. Once I've got that, that gives me my place value. 5.41 times 10 to the power of 5. The 5 goes in the power bit. So it'll be 5, 4, 1, and then to keep them out there, 0, 0, 0.
So the 5 always goes to...
So whatever that number is there, that matches that.
Okay,
So that goes into that column, and then the rest of the number follows. So with this one,
so the 2 is going to be where the 10 by the power of 4 will be.
2 goes there.
Oh, okay, I get you.
3, 0, 0, 0. Okay? Now they're asking me to add these together. And all I'm adding are the numbers that I've written, yeah, not the powers. So 0 plus 0 plus 0 plus 4 plus 6 plus 5. So the number is actually 564,000.
So would you put by the power of...
So in standard form, it's going to be, the biggest part of it is in the 10 to the 5. So it'll be 5.64 times 10 to the 5.
Okay.
If it was a subtraction, you'd do exactly the same.
That's going to be minus.
Yeah.
Times better minus.
But no, you would do the same thing. So if we were subtracting those, we'd have 0, 0, 0. Then we'd have to borrow from that. You'd end up with just a different set of digits. And then you turn it back in the same way.
So you always put the decimal to...
It's always it's always a number between 1 and 10, that part of it.
Okay.
Okay? So let's say, for example, it was just that.
Yeah.
Okay? Then it would be 4 times 10 to the 3.
Okay.
If you got 2 bits,
So 6.4
times 10 to the 4.
okay.
Okay?
Okay.
So that's multiplying, adding and subtracting. Multiplying and dividing is slightly different,
It's actually easy.
but that's the easiest way to do it. Marks for that one. So 1 mark would be if you did it and left it like that, not put it back in the standard form. 2 marks, they want the answer back in standard form. And then we've got one last question, which I've kind of given you all the skills to do this.
I've touched upon this.
Okay, it's like an equation, but it's an inequality. So Rashid owned N sheep. Ivion has exactly 4 times as many sheep as Rashid. So if Rashid has got N, 4 times N is 4N. Rashid buys 17 extra sheep. So that'll be N plus 17. Ivion sells 8 of his sheep. So that would be 4N. Take away the 8 he's sold. Ivion still has more sheep than Rashid. So Ivion's 4N take away 8 must be greater than Rashid's N add 17. Okay, that's forming the inequality. If the question had said, after buying and selling, Ivion and Rashid had the same number of sheep, that would be an equal sign.
Equals.
Yeah? If it said that Ivion then had more, you'd write them the other way around, or the inequality would point the other way. The inequality always points to the smallest quantity. Okay? Now we solve it like an equation. So I'm going to take that 17 off, which means I'm going to take 17 off there as well. That means that this side I've got 4N take away 25, and on this side I've got N. Now I'm going to take N off, and if I take N off there, I've got to take N off there as well.
4 minus 2.
So I get 3N.
Oh, for me?
Yeah,
Oh, because
4N take away 1N, yeah? 3N minus 25, N take away N is 0. Now I'm going to add 25. Got to do it to both sides. Leaves me 3N on that side and 25 on that side. To get the N on its own, I've got to divide by 3. Gives me that. Okay, so that's going to be 8 point something. Whatever.
Oh, 8. Yeah.
Okay. So go back to your question. Find the least value of N. So the number of sheep have to be greater than 8 point something. So how many sheep?
No, it could be 7.
Can't be 7, it's got to be greater than 8 point something.
Oh, so it's much bigger than 8.
It's got to be bigger than 8
Oh,
point
so like
something.
9 or 10.
So it's 9. The smaller, it could be 10, it could be 1,000, but the smallest value is 9.
And it goes up.
N is 9. Is the smallest. Because it's an inequality, it means it doesn't matter what it is, as long as it's bigger than it. Okay, so that's quite tricky, but this bit is 2 of the marks for forming that. Then, if you can solve an equation, you can solve the inequality. So there's 1 mark for getting it down to 3n is greater than 25. 1 mark for figuring it's going to be greater than 8 point something, or to turn that into a mixed number. 3 goes into 25 8 times, remainder 1 and a third. Okay, so it's 8 and a third, so the smallest whole number bigger than that is 9.
So that would be.
And there's the last mark. Okay? So there's a few topics there, like I said, that we didn't cover. Dimensions, you really got a grip of that quickly, so that's worth you having a little look over the weekend or whatever. But that was really good.